Hello everyone, welcome to our database system video. Today we'll be teaching you about chapter 3, entity relationship diagram. Let's start off with our first subtopic, characteristics of relational table.
Hello, my name is Adlil and I'll be talking about the characteristics of a relational table. So a relational table is a two-dimensional table that consists of a tuple, a row, and a column. And each row is defined as an entity, and each column is defined as an attribute. And other than that is that in a relational table, it will have a primary key and a foreign key. The foreign key will depend on the data that is inserted into the table. Other than that also is that if a intersection between a tuple and a row like this, that is called data.
Talking about the keys. So in our database system subject, we are going to learn about 6 keys, which I'll explain now. So the first and foremost is the primary key. The primary key is an attribute that is unique, that can identify the row, which is the entity. So for example, primary key is in the student entity, would be the student ID, because in student ID is the only unique attribute. For example, student name, there can be 2 students that name John and John, Mary and Mary, you get the point. And age, they could be the same also, but an ID is unique. Whereas the foreign key is basically primary key in this entity or any other entity that will go to another entity. So for example, subject code, which is under student, is from the subject entity. So subject code is a primary key here, and when it transfers to another entity, it will be a foreign key. Now, a secondary key is basically all the other keys, not all the other keys, but other keys besides the primary key and foreign key. It's just strictly for data retrieval method. Right? We're talking about the remaining keys, which are the super key, candidate key, and composite key. So a super key is basically an attribute that can instantly identify the entity, whereas the candidate key is basically a super key, but without the redundancies. Alright? And a composite key is basically a key with 2 or more attributes, and that's it.
Discussing about dependencies. So, dependencies is where the key will be based on the concept of determination. So, that one particular key will determine the value of the other keys. So, there are 2 types of dependencies: for functional dependence and functional dependence. So, let's talk about functional dependence. In functional dependence, we have 2 concepts: determinant and dependent. So for determinant, this key will determine the value of the other attributes. And for dependent, for example, this key will be determined by the determinant. So for example, student ID will determine all these values of attributes. But for dependent example, student number, to access student number, you need to rely on student ID. So basically, student number is dependent on student ID. So for full functional dependence, the concept is just the same as functional dependence, but on an entire collection. So for student ID, this student ID will determine the whole attribute in this one column.
I'll be explaining about integrity rules. As integrity rules states that primary keys are unique and they cannot have null values. Null values means there's no value at all towards the primary key. As you can see here on the table, each row has a different and unique kind of entity. This is student, lecturer, and subject. And each of the rows have different primary keys which are not similar at all. This is student ID, lecturer ID, and subject code. These are all the primary keys stated there. The purpose of it is so that when you want to search your data over in your computer or your laptop which you saved, you can find it by referring to student ID. Just search student ID and all the data of the students will come out. the requirements are for foreign key is that so that foreign key does not lose its data. As you can see here, foreign key is under student, but it's also a primary key under subject. So it cannot lose its data. That is why it's said as foreign key. For example, is I'm sure all of you all have bought things online and you all would receive an invoice, and you can see the invoice code will always be different and be unique, and it cannot be null value. Foreign key. As you can see here, there's a foreign key here which is under subject code, and there's a primary key here for subject code 2, but it's in 2 different columns. So a foreign key can have no value, so that it can refer to the primary key over here, but it cannot have an invalid value. I'm trying to say that both the subcode, subject codes must have same value, so that the data does not crash. The purpose is so that the subject code can always, the foreign key under the student can always refer back to the primary key under the subject. For example, a student can not be assigned to a subject yet, but he cannot be assigned to a subject where it is not given in that semester.
Okay, now I'll be explaining on ERD, which is the entity relationship diagram. Now, an ERD is used to display a conceptual database to the end user. And inside an ERD, inside a database, there are 3 main characteristics, which are entity, attributes, and relationship. Now, the characteristics of an entity are required attributes, optional attributes, domain, identifier. Now, I'll go on to explain what these 4 are. Required attribute means that your attribute must have a value. Optional means it can have a value or it cannot have a value. Domain is the unique set of values given to your attributes. Identifier is what is used to uniquely identify your attribute. Now, moving on to attributes in general, there are 5 attributes: composite, identifier, composite attribute, simple attribute, single value, and multi-value attribute. Moving on to relationships, for ERD, you need relationships to connect the tables to each other. And inside your database, you need participants, connectivity, cardinality. Participants are the entities in your database, which are in your ERD. Connectivity is what connects them together. Cardinality is it expresses the minimum and maximum members of the relationship. Now, as you all know, we learned 2 types of ways you can design your ERD. One using the chain model, which is this. Second is crow's foot. Okay. Now, for most part, I'm going to be explaining on crow's foot, and these are the symbols that you can use when you are designing an ERD using the crow's foot. First one is optional to many, mandatory to many, optional one, and mandatory one. Okay. Now, there are 3 type of relationships that we usually use, which are one to many, one to one, and many to many.
Alright, today we're gonna show you about the cardinalities of one to many to many, and one to one. Let's start off by one to many. We're gonna use the crow's foot model. So based on this business rule, one student should at least have 1 or more subject. So if you look at this trigger word here, should at least have 1 or more subject. So we're gonna use the symbol mandatory many. So based on this crow's foot model that I have made, so the entity student should have at least 1 or more subject, and we need to write this symbol here, one and many, and also this one, the keyword has, and also the subject can have 1 student. The next cardinality or relationship would be many to many. So based on the business rule given, an author can write many books, and a book can be written by many authors. So this is a many to many relationship. So based on the model given, the author can write many books. So mandatory many, and the book can be written by many authors, many to many. So the reason why there is a bridge table here is because we cannot have two mandatory manys at two entities because it will cause a data redundancy. So logically, the authorship would be the best entity here because the contributor can either support the author name. The contributor can support the author or can support the author itself by buying the book. Point and review.
Alright, so next up, one-to-one relationship. So one-to-one means mandatory one to mandatory one, alright, or either optional to optional. So in this type of sentence, the keyword is like this. So a customer can only pick one product, and a product can only be sold to one customer. So the one product to one customer, that's the obvious keyword that this is a one-to-one relationship. Alright.
We are going to be discussing about how to change this business rule into a crucible ER diagram. So firstly, we have to find the entities first. So in this business rule, the entities are student, subject. Only two. So yeah, it will be much easier to convey to you the knowledge. Okay, and then after finding the entities, we have to find the attributes for the entities.
And the ones that are inside will be student ID, student name, and subject code. While underneath subject will be subject code, as required, student ID, and room ID.
And then after we found the student, the entities and the attributes, we have to determine what's the primary key and foreign key for each of the entities. So basically, the primary key for student entity is student ID.
The one for subject will be subject code.
And then for the foreign key for both for the student entity is subject code, because if you see here, the subject code is here and then here.
The same could also be said with subject in regards to student ID. Student ID would be the primary key of student, but it is also underneath subject in terms of being an attribute towards it.
So let's start building our ER diagram.
Okay, first it will be. First, let's make our student table.
Yeah.
Okay.
And put in attributes.
Student underscore ID. Okay, first of all, it will be student underscore students. Okay. Student underscore name.
Student and subject.
And also subject code.
Okay, so you see here. So you see here, PK is the primary key, student ID, and then FK is the subject code, foreign key. FK is foreign key, PK is primary key. And then after that, we will draw the entity of subject.
Okay, here's the subject table. Okay, okay, it will be hours required. Student underscore.
It have to be the same. The name.
Yeah.
So,
Okay. You recap that part or something?
okay. Same as subject, we have to have the primary key, which is the subject code, and then the foreign key, which is the student ID. And then after we've done this, we have to find, we have to determine what's the cardinality between the student and the subject.
It says a student must select at least one or more subjects. while a subject a subject must have at least one or more students. So it can be determined that both of them are mandatory. But
That's how it's presented. That's many to many. We can't do that really. So we have to change the many to many to one to many, or basically one to many, because this is many to many. So yeah, we have to change the many to many.
So it's better for us to make a bridge table.
Yeah. So build a bridge table.
So we use this. And let's go with bridge table. What we call the bridge table would be something like enrollment. And what you would have inside would be something like so ID and something extra like date. Date underscore entry, something like that.
So this is our bridge table now. So now we can properly connect the two entities together. So how you do it is based on this bridge table. So for enrollment, the student must at least enroll one or more subjects. So mandatory many. And enrollment will have to have only one student at a time to enroll. And then same goes for the subject. Subject has to give out one or many of their subject group and such.
As you can see from this bridge table, it currently connects between student and subject without creating any more redundancies than necessary.
Data redundancy is a big no-no in the database system, right? So yeah, this will reduce the data redundancy of this AR diagram. So yeah, that's it for us. So thank you.